Hello everybody. Okay, so what we've got here now, we have the Hubble telescope. We are tracking it, and yes, I've done this before, but I've been asked if I could use an LCD i2c 1602 instead of using the Pico 114 or the OLED screen. I've already done it with them, or even the Nokia display, which not many people have. So I will use this one now because this is what people want. So we'll give them the viewer I've asked for. Okay, so this is the way it works, is that we track the distance of, we track with the latitude and the longitude of the Hubble telescope. Once we know the longitude and latitude of the Hubble telescope, then we take in this case, my latitude and longitude, which is in Cape Town, and we apply a formula called the Haversine formula, which I need to calculate the distance between my position and the Hubble Space Telescope latitude and longitude, which I tracked it, I've got it, and I bring it into the sketch, and then I need to use a Haversine formula, which will provide me with the circle distance between 2 points on the Earth. Okay, got it. And that is the way it works. And you can see here at the bottom is the way it works, is exactly as I've explained it now. But I will put a link on YouTube sites. Okay. So here's a circle of the, well, it's not the circle of the Earth, because it's circle of the Earth is about 15,000, 16,000 kilometers across at the equator, I think. Okay, here we are. There's one thing that I need to do, I think is, okay, let me see here, the latitude and longitude. Okay. I think a delay here, maybe 4 seconds, because you can't explain it while you keep on. Okay. Just want to see. I wonder if it's 61. Can't remember the port. I had something else attached. Okay, 61. Yes, let's date. Okay. See there, I just need to get the latitude and longitude to stay longer, because it just leaves too quick. And that is a latitude and longitude of the Hubble telescope. Here we are. So the latitude is 2.85 and the longitude still, I need to get more time. Okay, so the distance is 11,000 kilometers now from me to the Hubble telescope, and the longitude is 121. Okay, so at the moment, because the figures are all positive and not negative, the latitude and longitude, it means that from my side is very far north, is on the northern hemisphere, and I'm the southern hemisphere. I'm below the equator, and there is no minus figure here, so it's above the equator. Okay, so that means that the Hubble is above the equator, and it's 11,000 kilometers away from me. All right, there we are, 1.44 and 0.23. Once you get a minus longitude or latitude, it means it's moving toward, it's on the southern hemisphere. Yeah. Okay, I don't think there is much here, except that there is a few things that I want to explain on the codes that you must remember always. The first thing is your username and password. You put them here. Okay. The SSID, it's the name of your router or whatever, your network. And the password is your password, whatever you got. Then you must make sure you got all these, you must make sure you got the library uploaded. You can download it from here. You go here and you put the name of a library and you install them, okay? This is the library of your IDE, Arduino IDE. Okay, this is the i2 sites, i2 n2u.com, which is, it's a website that allows you to use an API key to track satellite. And then you bring towards your program, and then you calculate it. You have a formula to measure, you know, once you know the latitude and longitude of a spacecraft, you can work out its position and on the Earth and measure with your distance and so on. It's actually quite fun. It's a good project for school as well. This is my position, longitude and latitude. Oh, one thing that sometimes you have to remember, even if you might change this and use in this case, you can use an Arduino with no network, with no wireless, but if you have to, in that case, you will have to use GPS. And without a GPS, you can use the network system, the internet, the NTP will be able to work much better and faster. Okay, so in this case, you change your screen display. Sometimes you gotta put wire begin, because this is SDA and SEL, and it requires to be initialized. Sometimes depends on your library. In this case, this library is a problem. If I have wire begin without a D2 and D1, which are these two pins here, this one is the brown as SCL and SDA. It's D1 and D2. And if I don't put them on the wire begin, it will give me an error message and I can't carry on. I can't upload the sketch. Okay, so this is problem number one. The other problem that I have with, particularly with the liquid, the liquid crystal i2c, this one here, is that every time I use LCD dot begin, if I don't put 16,2, which is, or you can put this one as well, which is the parameter of your screen, it will stop here, it won't work. So you gotta know what you put in here, because this is another problem that repeats itself. And yeah, and if these two are the main cause of the screen not functioning. If you don't put this one, it won't clear, it won't show anything on the screen. And if you don't put these numbers, this parameter on, it'll freeze us here. It won't progress, won't go ahead. Okay, so remember that. Okay, here, for example, in the case we have connecting. While you're connecting, LCD set the cursor to 0, 0. Because connecting comes first when you're busy connected. So you'll see here, when you start, connected to the Hubble, okay? It's to the Hubble, it's underneath, okay? Connecting, it's 0, 0. To the Hubble, it's 0, 1. And I'll show you here. Okay, so you see 0, 0 connected, and then 0, 1 to the Hubble. So now you're connecting to the Hubble. It's display on the beginning of the block, but it's line 2. In this case, it's line 1, and this is line 0, and it's 0. It's the beginning of the block where it starts. Okay, delay delay 1 second, delay 2, 2 seconds. You can change your delay. Same is going to be on the latitude and longitude. Okay, I will print here connected when he's connected. This will communicate to, this will tell when it's connected. Okay, so serial will print that is connected, and the LCD will take that connection and display connected on the screen. Okay, in this case, if you don't put 0, 1, it'll come on top as default. It's only you put 0, 1 if you want to add another one to 0, 0, 0, 0, and you want one to 0, 1, and then you have to specify the positioning. Okay, so there we are, and we carry on down, and we go HTTP. This is the HTTP connection to the website that is connected, so it doesn't show error 400 that you haven't got connected yet. And this is the HTTP response code, the speed, the timing to connect to the internet, which is the website of N2U. Okay, so the satellite search, here we hold that, and then we go to the screen again, and here we have set the cursor to 0, 0 for the latitude and 0, 1 for the longitude. And you can see on here that the latitude will be here, and that is 0, 0, and the longitude it's 0, 1, because it's on the second line, 0, 1, okay? And that's where it appears. Okay, the Hubble now, remember that the Hubble goes like waves. It's like a waves up and down. So sometimes now it hit the southern hemisphere by 13.04. It's on the southern hemisphere. Don't know for how long before it bounces back on the northern hemisphere, because it's on the equator. This is very close to the equator. All right. Okay, I think we've covered quite a bit. Remember as I said, the formula. You need to, once you brought the latitude and longitude of the Hubble telescope, you will need your longitude and latitude. Then you will need the Haversine formula to calculate the 2 great point distance on Earth to connect, to give you the distance of the Hubble telescope from your positioning. All right, guys, I think we've covered almost everything. And yes, have a good day. Please give me a thumbs up if you like it. And have a good day.